Introduction. Students, we all are familiar about the polythene and its amazing uses. Nowadays, polythene bags are of popular type and are available in diverse forms and shapes. The present global volume of polybags produced worldwide is several trillion units. Most of the retailers use polythene film as it is the most common type of packaging. Universality of polythene has rendered them virtually irreplaceable. The printed bags are used and are available in attractive colors, designs, and different shapes are very eye-catchy. Polythene is just an example of polymers. There are a number of polymers that we are using in our everyday life. So students, today we will study about the polymers. Objectives. At the end of this lesson, you will be able to define polymers, define homopolymers and copolymers, classify polymers, explain types of polymerization reactions, describe free radical polymerization, understand different polymers, know about rubber, calculate molecular mass of polymers, define biodegradable polymers. Definition. A polymer is a compound of high molecular mass formed by the combination of large number of small molecules. Polymers are the chief products of modern chemical industry, which form the backbone of present society. In our everyday life, we use number of materials like plastic dishes, cups, automobile tires and seat covers, plastic bags, raincoats, radio, TV and computer cabinets, wide range of synthetic fibers of clothing, synthetic glues, flooring materials and material of biomedical and surgical operations are based on polymers. Homopolymers and copolymers. The small molecules which constitute the repeating units in a polymer are called monomer units. The process by which the monomers are transformed into polymer is called polymerization. For example, polyethylene is a polymer which is obtained by the polymerization of ethylene. The ethylene molecules are referred to as monomer units. Polymers are divided into two broad categories depending upon the nature of the repeating structural units. Homopolymer. The polymer formed from one kind of monomers is called homopolymer. For example, PVDF is formed by vinylidene fluoride. Copolymer. The polymer formed from more than one kind of monomer units is called copolymer. For example, Buna S rubber is formed by 1,3-butadiene and styrene. Classification of polymers based upon source. Under this type of classification, there are three subcategories. Natural polymers. Polymers found in nature, mostly in plants and animal sources, are called natural polymers. For example, polysaccharides, proteins, nucleic acids, and natural rubber. Polymers like polysaccharides, nucleic acids, and proteins, which control various life processes in plants and animals, are called biopolymers. Semi-synthetic polymers. These are mostly derived from naturally occurring polymers by carrying out chemical modifications. For example, cellulose diacetate. Synthetic polymers. The polymers which are prepared in the laboratory are referred to as synthetic polymers. For example, polyethylene, synthetic rubber, nylon, PVC, and teflon. Classification of polymers based upon structure. Under this type of classification, there are three subcategories. Linear polymers. These polymers consist of long and straight chains, for example, polyvinyl chloride and nylon. Branched chain polymers. These polymers contain linear chains having some branches. For example, low-density polyethylene and glycogen. Cross-linked polymers. These polymers are usually formed from bifunctional and trifunctional monomers and contain strong covalent bonds between various linear polymer chain. For example, bakelite and melamine. Classification based upon the mode of polymerization. Under this type of classification, there are two subcategories. Addition polymers. The monomer units are repeatedly added to the growing polymer chain without elimination of any byproduct molecules. The polymer has the same empirical formula as its monomer. The monomers are unsaturated compounds, usually derivatives of ethylene. For example, polyethylene. Addition polymers can also be obtained by addition polymerization of two different monomers. For example, Buna-S. Condensation polymers. These polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. The condensation polymerization reaction is generally accompanied by elimination of small molecules such as water, alcohol, or HCl. For example, nylon 66 is formed by condensation of hexamethylene diamine with adipic acid. Classification of polymers based on molecular forces. Under this type of classification, there are four subcategories. Elastomers. The polymers in which polymer chains are held together by the weakest intermolecular forces. These weak forces permit the polymer to be stretched. A few crosslinks are introduced in between the chains which help the polymer to retract to its original position after the force is released. For example, vulcanized rubber. Fibers. The polymer which are used for making fiber possess high tensile strength and high modulus. There are strong intermolecular forces of attraction like hydrogen bonding. These strong forces also lead to close packing of chains and impart crystalline nature. For example, nylon 66. Thermoplastic polymers. The intermolecular forces of attraction in thermoplastic polymers are moderate. Therefore, they can be easily molded by heating. There is no cross-linking between chains in thermoplastics. For example, polyethylene and polystyrene. Thermosetting polymers. These polymers are made from low molecular mass semi-liquid polymers, which when heated in a mold become infusible and form an insoluble hard mass. There is extensive cross-linking between different polymer chains, forming three-dimensional networks of bond connecting polymer chains. For example, bakelite. Types of polymerization reactions. There are two types of polymerization reactions. Addition polymerization or chain growth polymerization. This type of polymerization involves successive addition of monomer units to the growing chain carrying a reactive intermediate such as a free radical. Depending upon the nature of the reactive species involved, addition polymerization occurs by three mechanisms: free radical polymerization, cationic polymerization, and anionic polymerization. Condensation polymerization or step growth polymerization. It occurs through a series of independent reactions. Each step involves the condensation between two bifunctional monomer units with elimination of simple molecule such as water or alcohol and lead to the formation of the polymer. Since the polymer is formed in a stepwise manner, the process is called step growth polymerization. Free radical polymerization. The initiation of the polymer chain growth is brought about by free radicals produced by the decomposition of compounds called initiators. For example, ethylene polymerizes by free radical mechanism when it is heated at a pressure of 1000 atom with a small amount of an initiator, which decompose to produce free radicals. Free radical polymerization occurs through the following steps. Chain initiation. The initiator decomposes to form free radicals. The free radical R dot adds to the double bond of the alkene monomer to form a new free radical of larger size. Chain propagation. The repetition of the above sequence with new and bigger sized radicals propagates the reaction. Chains propagate by adding successive ethylene units until their growth is stopped by combination or disproportionation. Chain termination. The radical at the end of the growing polymer can also abstract a hydrogen atom from itself. Chain branching. This leads to chain branching. Polythene. Polythene is the most widely used addition polymer. Nowadays, two types of polythenes are produced and they have widely different properties. Low-density polythene. It is manufactured by heating ethylene to 350 to 570 Kelvin under the pressure of 1000 to 2000 atom in presence of dioxygen or peroxide. Polythene thus produced has a branched chain structure. Due to branching, molecules do not pack well and hence it has a low density and a low melting point. Low-density polythene is chemically inert. It is tough but flexible and a poor conductor of electricity. It is widely used as a packaging material. It is used as insulation for electric wires and cables in the manufacture of toys. High-density polythene. It is manufactured by coordination polymerization of ethylene. Ethylene is heated up to 330 to 350 Kelvin in presence of Ziegler-Natta catalyst. The polythene thus produced consists of linear chains of polymer molecules. As these chains pack well, this polythene has higher density and higher melting point. Higher density polythene is a translucent polymer. It is chemically inert but has high tensile strength, toughness and hardness. It is used for manufacturing of pipes, buckets, dustbins and other household goods. Polypropene. The monomer of polypropene is propylene. It is produced by heating propylene in presence of Ziegler-Natta catalyst. Normal radical chain polymerization produces highly crystalline isotactic polypropylene. It is harder and stronger polymer than polyethylene. It is used for packing textiles and food. It is used for making automobile seat covers, carpet fibers and robes. It is used for making water pipes and washing machine parts. Polytetrafluoroethylene, Teflon. The monomer unit of polytetrafluoroethylene is tetrafluoroethylene molecules. It is prepared by heating tetrafluoroethylene under pressure in the presence of ammonium peroxosulfate. It is a very tough material and is resistant towards heat, action of acids or bases. It is a bad conductor of electricity. It is used in coating utensils to make them non-sticking. It is used in making seals and gaskets which can withstand high pressures. It is used as insulations for high-frequency electrical installations. Polyacrylonitrile, PAN. It is a synthetic, semi-crystalline organic polymer resin. The addition polymerization of acrylonitrile in presence of a peroxide catalyst leads to the formation of polyacrylonitrile. Though it is a thermoplastic, it does not melt under normal conditions. PAN fibers have good resistance to stains, chemicals, insects and fungi. It is used as a substitute for wool in the manufacture of orlon, which is used for making clothes, carpets and blankets. Polyamides. The polymers having amide linkage in the chain and are called polyamides. Nylon 66. It is a polymer of adipic acid and hexamethylene diamine. It can be cast into a sheet or fibers by spinning devices. Nylon fibers have high tensile strength. They are tough and resistant to abrasion. They are also elastic in nature. It is used in making bristles and brushes. It is used in making carpets and fabrics in textile industry. It is used in elastic hosiery in the form of crinkled nylon. Nylon 6. It is obtained from the monomer caprolactam. Caprolactam on heating with traces of water hydrolyzes to 6-amino-caproic acid, which on continued heating undergoes self-condensation and polymerizes to give nylon 6. It is used for the manufacture of tire cords, fabrics and robes. Polyesters. Polymers that contain ester linkages are called polyesters. These are prepared by condensation polymerization of diacids with diols. Terylene. Dacron. It is prepared by condensation polymerization of ethylene glycol and terephthalic acid. The polymerization is carried out at about 420 to 460 K in presence of a catalyst consisting of zinc acetate and antimony trioxide. The fiber of terylene is strong, crease-resistant, durable, and low moisture-absorbing capacity. It is used to manufacture wash and wear fabrics, tire cords, and seat belts. It is used for blending cotton and wool to provide better finish and increase their resistance to wrinkles and wear and tear. Phenol formaldehyde polymer, bakelite. These are made by the reaction of phenol and formaldehyde in basic medium. Bakelite is a cross-linked thermosetting polymer. Soft bakelites with low degree of polymerization are used as bonding glue for laminated wooden planks in the preparation of varnishes and lacquers. High degree of polymerization leads to formation of hard bakelite, which is used for making combs, fountain pen barrels, gramophone records, electrical goods, and many other products. Sulfonated bakelites are used as ion exchange resins for softening of hard water. Melamine formaldehyde polymer. Melamine and formaldehyde co-polymerize to give melamine formaldehyde polymer. Melamine polymer is quite hard and is used in making plastic crockery, cups, plates and other articles made from melamine polymer do not break on being dropped. Natural rubber. Natural rubber is a mixture of organic compound polyisoprene and small amounts of other organic compounds as well as water. It is derived from latex, a milky colloid produced by some plants. The plants are tapped, that is, an incision made into the bark of the tree and the sticky, milky colored latex collected and refined into a usable rubber. Vulcanization of rubber. The process of involving more crosslinks in a rubber and altering its structure so that it becomes less plastic and sticky, more resistant to swelling by organic liquids, and has enhanced elasticity. The rubber is heated with sulfur. It is used for making automobile tires. Synthetic rubber. Those rubbers which obtained by polymerization of butadiene or its derivatives are called synthetic rubbers. They are heat resistant, oil and solvent resistant, more elastic and have more abrasion resistance. Preparation of synthetic rubbers. Neoprene. Neoprene is formed by the free radical polymerization of chloroprene. It is resistant to heat. It is resistant to vegetable and mineral oils. It is used for manufacture of conveyor belts, gaskets and hoses. Buna-N. It is obtained by co-polymerization of 1,3-butadiene and acrylonitrile. It is resistant to petrol, oil and organic solvents. It is used for making oil seals and tank lining. Molecular mass of polymers. During the formation of polymers, the growth of the polymer chains depend upon the number of monomers available in its vicinity. As the number of available monomers differ from one place to another place in the reaction vessel, so a polymer may contain chain of varying lengths and therefore its molecular mass is always taken as an average. This average is called weight average molecular mass. The ratio of these types of molecular masses is called polydispersity index. In natural polymers, the value of PDI is unity, but in synthetic polymers, the value of PDI is greater than unity. PDI is used to determine the homogeneity of a polymer. Biodegradable polymers. Biodegradable polymers can be broken into small segments by enzyme-catalyzed reactions. The required enzymes are produced by microorganisms. The carbon-carbon bonds of chain growth polymers are inert to enzyme-catalyzed reactions, and hence they are non-biodegradable. To make such polymers biodegradable, we have to insert certain bonds in the chains so that these can be easily broken by the enzymes. The best method of making a polymer biodegradable is by inserting hydrolyzable ester group in the polymer. For example, if acetal is added to an alkaline undergoing radical polymerization, ester group will be inserted into the polymer. The weak links in the polymer are susceptible to enzyme-catalyzed hydrolysis. Polyhydroxybutyrate co-beta hydroxyvalerate. It is a copolymer of 3-hydroxybutyric acid and 3-hydroxypentanoic acid. It is used in orthopedic devices and controlled drug release. The drug put in PHBV capsule is released after this polymer is degraded by enzymatic action. Did you know? Polythene needs about 450 years just to start decomposing. Then it takes another 50 to 80 years to decompose completely. 90% of the price you pay for the bottled water goes to the plastic bottle, while the water costs you only 10% of the money you give. The worldwide fishing industry throws huge amounts of polythene garbage in the oceans. 150,000 tons go into the water every year, including packaging, plastic nets, lines, and buoys. Summary. Let us summarize what we have learned. A polymer is a compound of high molecular mass formed by the combination of large number of small molecules. In addition polymers, the monomer units are repeatedly added to the growing polymer chain without elimination of any byproduct molecules. Condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. The polymers in which polymer chains are held together by the weakest intermolecular forces are known as elastomers. Thermosetting polymers are made from low molecular mass semi-liquid polymers which when heated in a mold become infusible and form an insoluble hard mass. The polymers having amide linkage in the chain and are called polyamides. Natural rubber is a mixture of organic compound polyisoprene and small amounts of other organic compounds as well as water. Biodegradable polymers can be broken into small segments by enzyme-catalyzed reactions. The required enzymes are produced by microorganisms.